Okay.
Hello ladies and gentlemen of Year 7. This is Mr. King here, for those of you who don't know me, and I'm currently in 503 in a very weird, quiet school. And we are going to go over today how we set up and start our first assessment for Term 2. And it's all on forces. You all have a copy of this by now, and we are going to run through this experiment so you know exactly what it looks like from our perspective. There's a bit of a blurb here on forces and cars, and we're going to use something very similar today in our experiment. And there is a few things that you need to fill out as we go through. You'll also see that we're going to do 5 different tests throughout today, and you're going to get the results to be able to do something with those results. So, on page 8 of your assessment, you will see some materials lists that you guys need to fill out. On our materials lists today, we have a balloon, at least one, so different coloured balloons here. We have some string. We also have our little balloon car, which you can see here. In the actual diagram, you'll see that they are very similar. It's not exactly the same, but similar kind of design. Basically, just a car shape, 4 wheels, and a place to fit the balloon. We've also got our stopwatch, just as per normal, stop, start, which you guys are used to. And we also have some measuring tape. So all of those materials can be written down on page 8 in this particular column. So next we're going to discuss the variables, and the variables can be found on page 5 of your worksheet here. Now, variables are very, very important, as you'd be aware in science, and today we're going to test one of the main variables. This particular thing is going to be our independent variable, and as you probably remember from the cows moo softly part, an independent variable is the thing we change. Now today what we're going to do is we are going to blow up a balloon, put it through the car, let the car go and measure how far it goes. So you might be thinking, well, the measurement is our independent variable. That would be incorrect. The correct thing to think about here is that our independent variable will be the size of the balloon. And I'll give you a demonstration. So this, for example, may be our smallest size. So I can inflate it more. And obviously when I inflate it more and let it go, you will see that more force is likely to come out of the balloon. We can therefore assume the larger the balloon, the more force is applied to the car and the further it can go. So our independent variable, the thing that we are likely to change, is going to be the size of the balloon. So our second question then is, how will you vary it? That's up for you to work out. The third is, what is your dependent variable? And again, from cows moo softly, the moo part is the bit that we measure. And the thing that we are going to measure here is how far, so the distance that the car travels given the size of the balloon. And we'll discuss that next. So now we're going to show you exactly what we do with the balloon. As you can see, I've attached the balloon through our toy car here. On the version that you've got in your assignment, it's slightly different, but it's the same concept. So what I'm going to do now is I'm going to inflate the balloon to a certain circumference. So how around or how far around. And Miss Hahn in a second is going to show me or help me to measure how far our balloon is in its circumference. So I'm just going to blow this up for a second. And we've got our balloon still attached. And you can see if I zoom in on the end there, it might be a bit hard to see. When I release that, you can probably see that it's going to provide some force, and that force is going to mean that this balloon car is going to move in a forward direction. So let's hope that works. We'll demonstrate it in a second for you. So what I have here is my balloon. It's fully inflated. I've got my finger on it. Obviously when I let it go, it's going to start moving. So I don't want to let go. I'm going to need a hand here. And Miss Han is kindly going to help us. And what she's going to do, she's going to measure around the outside of the balloon with some string. And as you can see there, string's really good for this because obviously it's not a straight line. It does provide a straight line though when we straighten it at the end. So Miss Hans found exactly where it is, and then she's going to go to our measuring tape, which we've got just down here. And she's going to see how long it is. And this, for example, was 54 centimeters in diameter. So 54 centimeters around here. As you can see, with your experiment, you can see, and I'm going to have a look in that middle column there, you can see there are different circumferences of the balloon. So in this case, we have a 40, 50, 60, 70, and 80 circumference or centimeter circumference of the balloon. So here we have just outside in the hallway our balloon, inflated, ready to go. I've also got my tape for some measurement purposes here. In a second, I'm going to release my fingers off the balloon and then hopefully we'll try and get a bit of a straight line and at the balloon car moving down. Whatever happens, you'll at least see the concept in motion. So I've got it started. I'm going to let my fingers go in a second and let's see. This balloon was just over 40 centimeters in circumference. So let's see how far it goes. Now, obviously we had a bit of a problem there in that it did hit the side of the wall, but that's okay. Remember, all data is usable, good data if we do things correctly. And what I'm going to do now is I'm just going to measure out, and this is easier if you've got someone else, and the results that you have got someone else. I'm just going to measure out how far away this balloon car went, try and keep it as straight as possible. Hard to do by myself, but the results you have will be a bit more useful. And I'll straighten it out as best I can and have a look. And in this case, the balloon car has travelled 2 meters and 95 centimeters. So 295 centimeters all in. So 295 centimeters. Now the results that you have, we have 5 different trials of this. Of the balloon, the independent variable, remember, is changed. We've changed the independent variable, how high the circumference or large the circumference of the balloon is. Should we do one more? So this is going to be our next trial. I'm going to make this one slightly larger. So this is going to be one of the larger circumferences to show you what the difference is likely to be. As you can see, I'm having trouble. That looks like a bigger balloon. So again, you can see our balloon is slightly bigger this time. This time I have already set out my measuring tape. Hopefully it doesn't run into it. And in a second, I'm going to do the same thing I did last time. I'm going to start at the same point that I started last time. I'm going to let it go and see what happens. I've got my theories. What are yours? Not very successful, that one. Interesting. Hopefully that gives you something to think about. I didn't change anything there, but there are different forces at play when there is a bigger balloon. And that is something you might want to think about in your assessment. And here we go again. Hopefully a bit of luck this time. Much better. So So in conclusion, as a general rule, as you'll see from the results we've concluded, when the balloon gets bigger, the circumference is bigger, we have had a greater distance of the balloon car travelling further in centimetres. And those results we've already given you.
Hi everyone, I'm Miss Carol from Sunny Bay State High. Please subscribe to this channel. I see you.